Hi, my name is Samuel Bakes, and this is computer vision. The uses of computer vision are many. For instance, optical character recognition takes a fuzzy looking image such as this and is able to decipher if it's a letter and if so, which one. There's also facial recognition, being able to take an image of a face and determining if it is actually a face. One of my personal favorites is the video filter, changing a mug like this into a mug like that. And we also have things like species classification. We can take an image with species or multiple species and determine what they are. Moving on, we're now going to look at how it works at a low level. For instance, here's an image, and this is how we see it. It's just to look at a picture of a face. How the computer sees things, though, is in binary. It sees these long list of zeros and ones. In fact, when I converted this image over to binary, it was much larger than this, and I had to cut some of it off to fit in the presentation. Now, this is how we get from an image to binary. What happens is that the image is broken up into things called pixels, and each pixel is classified as either black or white. And now after that, we take the pixels themselves and we assign values of 1 or 0, determined if it is black or white. After this, we take this image and we just break it into one big list of just binary zeros and ones to be decoded later. So that's the basics of how computers see images. It's just data. It's just zeros and ones arranged properly. Now, I know you're asking, the world is more than just black and white, and it is. And how we handle for color is something called a three-tuple. Basically, instead of having our pixel represented by just a 0 or a 1, we have it represented by an object with 3 properties, red, green, and blue. And now the reason we're using red, green, and blue and not red, yellow, and blue is because red, green, and blue contribute to what is called additive light. We can add green, blue, and red together and make white light, which is important because our screens are black. Red, yellow, and blue, as how artists mix their colors, instead of producing a nice light, whiter color, it produces a darker color. I'm sure you all remember as children adding the colors together to make a nice brown eventual black. This is why we use RGB instead of RYB. Anyways, each tuple will represent a pixel. Now, we're going to move on to the mid-level. When we get to the mid-level, I know of 2 really important things that we need to focus on. There's linear algebra, and afterwards we're going to talk about machine learning real quick. Linear algebra is very important to computer graphics. And because it's important to computer graphics, you bet it's important to computer vision. Basically, what linear algebra allows us to do is take sets of data and transform them. For instance, this little function here, it takes 2D image coordinates and produces 3D world coordinates. And it can do that because it can take the data it has, transform it using the linear algebra here, and that makes it into what they need. We'd use that a lot with linear algebra to make the data we need for machine learning algorithms. Now, when we get to machine learning algorithms, here we got something called a support vector machine. And what happens is basically we take 2 sets of data. We classify 2 sets of data. Like how we did with the initial image, we said black and white, 0 and 1. We can classify different ways. Let's say we classify color, red and blue, and we say all those are pixels. We can draw a line between those 2 different colors, which is important because with images, if you can tell, just look at a picture of myself, you can see the picture of me with my flesh tone face with brown hair, and you can draw a line through that, and you could have support vector machines draw lines and be able to produce sort of a way for us to find out the difference between me and the background. Okay, now let's get to the high level stuff. Here's how it works at the high level. OpenCV is a very useful open source tool that has thousands of built-in algorithms that perform at very high speeds because it needs to. That's available in C++, Python, Java, and MATLAB. Now, these tools are built for us to use and are extremely optimized, and we got to use, well, we use these things so we don't have to meddle around in the mid-level stuff. And we could just use that. Anyways, thank you very much for watching. And I hope you learned a lot. And if you have any questions, leave them in the comment section below. Thank you.